Welcome back, students. Let's resume our discussion on multiplication rules. We talked about earned models. Now let's talk about a little bit more realistic example. Previous examples were kind of like classroom example. It doesn't really happen outside classroom unless you play some game like that. But this one, as you can see, is quite realistic. Of course, in real life situation, insurance company will have more elaborate classification, but same kind of mathematics is being used. Let's see. An auto insurance company classified its customers as minimum risk, low risk, moderate risk, and high risk, depending upon their past driving records. The company estimates the probabilities that the aforelisted drivers getting into an accident within a month are about 1%, 3%, and 5%, and 10% respectively. So, minimum risk driver, 0.01, 1%. Low risk driver, 0.03. Moderate risk driver, 5%. And then high risk driver, 10% in a month. Of course, these numbers, I got it from a textbook. They're probably not real. But if you're running a real insurance company, then you're going to get a little bit more elaborate classification. And these numbers are, of course, actual figures. Other than that, we're doing pretty much the same thing mathematically. So, see what's going on here? So, depending upon what kind of driving habits, we get different probabilities for getting a collision. So, what kind of probabilities are these? Are these conditional probabilities, or are these just straight up probability? Straight up getting a collision? Straight up probability of getting into an accident? In that case, why are there 4 of them? The answer, these are conditional probabilities. Going into an accident if the driver is minimum risk. In that case, we have this conditional probability. Now, going into an accident if the driver is a high-risk driver. In that case, we have this probability. Alright? We're talking about the same event, having a collision within a time frame, a month in this case. But depending upon the condition, what kind of driver the selected driver is, we get different probabilities. These are conditional probabilities. Make sense? Alright, next. Also, the company estimates about 10% of the customers are minimum risk drivers. 30% are low risk drivers. And then 50% are moderate risk drivers, brown. And then 10% are high risk drivers. Now, what kind of probabilities are these? Are these straight up probabilities? Or are these conditional probabilities? If I select a customer at random, what is the probability that the selected driver is a low-risk driver, for example? Well, 30% of the customer base is low-risk driver, so yeah, that's going to be 30%, right? These are straight-up probabilities. Straight-up probability for minimum, low, moderate, and high, respectively. Okay, let's go here. Find the probability that a randomly selected customer of this company gets into an accident within a month. So accident. We're focusing upon that, accident. Getting a certain collision. Yes, if you're an insurance company, you want to know this so that you can set your insurance premium or whatever accordingly, and that you may want to do reinsurance or whatever. So basically, you want to find out probability of getting an accident. But then again, this must have something to do with this classification. So getting an accident from different type of driver. So how do you get all the probability here? The key observation is that you can do it this way. From minimum risk driver getting an accident from low risk driver having an accident getting an accident from a moderate risk driver finally getting an accident from a high risk driver. And this is a key observation. Does it make sense? So accident from minimum risk driver, from low risk driver. Actually, this is wrong picture. This is blue, and high risk is red according to this, and low risk is green, and moderate risk is brown. Okay. I used English term of from, and that does not look good. I should have used some mathematical, logical conjunction here. So, how should you rewrite this one here? Accident from a minimal risk driver, and use logical conjunction instead. Specifically, I'm talking about and versus or. Which one is it? Is it and or is it or? Accident or minimum risk. Or having an accident and the driver is minimum risk driver. Next is an accident and the driver that got into an accident is low risk. Make sense? They're all and. No or. And of course, this problem is coming from section 4, multiplication principle. So it's got to be and. You see, all problems are coming from section 2 of this notebook. When we associate those with Venn diagram, addition rule, in that case we have or, but here and. So if it's A and B situation, then it's got to be the multiplication rule. So multiply the probability of the condition times the conditional probability. Shall I look at this? That can be rewritten as probability of, let's see, this is A and B, and then we have probability of a minimum risk driver here, and then we have a conditional probability of minimum risk driver getting into an accident. So the condition part is minimum risk. So condition probability or probability of condition times conditional probability. That's the multiplication rule, isn't it? So that's the same as minimum risk driver times going to accident, given that driver is minimum risk driver. And then similar thing comes here. Accident, low risk driver, that's the condition, and then probability of the conditional probability. And finally, probability of And then, what is this? And what is this? This one, straight up probability, the proportion of minimum risk driver, 10%. And then the conditional probability O is here. So we can rewrite like this, that equals to 0.10 times 0.01. And that's the blue case, minimum risk case. And then the low risk driver, 30% of the drivers, times, in that case, conditional probability is 3%. That's green. And then moderate case, brown. And then finally, high-risk case. Not that many high-risk drivers, only 10%, but then again, the probability of getting into an accident within 1 month is pretty high, 10%. So if you calculate that, finally you're going to get the probability of having an accident one way or the other in any class. So basically we are using this rule over and over again and then adding those up for different categories. Now, were you able to follow all these? That's great. But then again, I told you about visualization through tree diagram, and look how much more easily this tree diagram explains the same thing compared with this. Getting the initial tree diagram can be tricky. Getting this is often difficult. And that's why I went through this to give you some idea. And then eventually my expectation is you can do this on your own without something like this is provided. Yeah, in elementary statistics class, whenever I write some tree diagram problem, I give the tree so that students can get these probabilities, conditional probabilities, and apply the multiplication principle. But the expectation is higher here, this 3000 level. So I'm not going to give you this tree, so you have to draw this at random. And it's often difficult to do that. And that's why I gave you this, to give you some kind of foundation, basis. What the heck we are doing? We want to get these accidents in all kind of categories and then adding them up, addition rule. But in order to get each of those probabilities, we need multiplication rules. And then in the end, we get that. But let's discuss the same thing using the tree diagram. So we have conditional probabilities and we have straight up probabilities, right? Straight up probabilities must be the first draw. And then the second draw will be conditional probability because something already happened in your first draw. I'm using the term draw to get a connection to the previous example of EARN model. So here, high risk, moderate risk, low risk, minimum risk, and then get appropriate numbers for these paths. For high risk, probability of high risk drivers, moderate risk, proportion of moderate risk drivers, and so on and so forth. And then here, I'm going to get conditional probabilities for having actual collision. For high risk drivers here, 10%. For moderate risk driver here, 5%. Low risk driver, 3%. And then 1% like this. Make sense? Well, here we go. So these are the distribution of drivers according to their driving habit: minimum risk, low risk, moderate risk, high risk. And then for each category, we have conditional probabilities of actually getting into collision in 1 month time frame, like this. And here I'm using color coding, red as actual accident and no accidents as blue. And then for the computation, now multiplication rule. Oh, no, excuse me. I have to run this to get this picture. So multiply. So for example, if you follow moderate risk driver and then getting into collision, you're following this path like this from here and following this path. So using multiplication rule, you're going to get this multiplication and this result for moderate risk driver getting into collision. This one instead is for low risk driver getting into collision. So I'm following this path. Each time I follow the path, I multiply. So in the end, that's what I get. And then of course I can do the same thing for the other drivers as well. And let's not worry too much about changing colors. So high risk drivers. So we get this multiplication rule. And finally minimum risk drivers, just following the path. So multiplication rule. So we have these 4 multiplications done, and then add them all up. And that's what we see here, down here, for collision. And of course, I can do the same thing for no collision as well. For no collision problem, it would have been a little bit harder problem because, read the problem, I gave you all those probabilities for collision, conditional probabilities for collision, but nothing for no collision. So what you should deduce from there is it's going to be the complement probability. So 10% of the time we have a collision for high risk drivers, so the other 90% no collision. For low risk drivers, 3% of collision, and the other 97% no accident, like that. And you can fill out those blue as well, and then multiplication rule, and then you'll have complete tree diagram. I prefer to complete the diagram first and then go through all those problems afterwards. But in this particular problem, I never ask anything about no collision case, so you can only do the red part. But if I asked you problem A, problem B, and then asked you a problem of a collision, and then another one about no collision, in that case, one way to handle it is to use this red and blue, and then use two different paths, and then adding them up. Of course, you can use complement probability as well. That may be a little bit easier. So, we just went through a tree diagram problem, and then theoretical background of the tree is this kind of computation. But of course, in the future, it's going to be a lot more convenient if you go directly to the tree. So do this exercises, and don't forget completely about these, because these are theoretical background, why this tree diagram is actually valid. But in reality, this is the way to go. And getting the initial tree is often difficult. Alright, remember, getting the initial tree is often difficult, and that's going to be particularly the case in the next lesson when we deal with Bayesian analysis problems. And these problems will be reproduced in lesson 3, and we're going to study these in far more detail in the next module.